Sample problem 16.16, caffeine. The stimulant in coffee and tea is a weak base that ionizes in water according to the equation. C8H10N4O2 aqueous plus H2O liquid forms HC8H10N4O2 plus aqueous and OH minus aqueous. A 0.15 molar solution of caffeine at 25 degrees Celsius has a pH of 8.45. Determine the Kb of caffeine. This is very much like one of the sample problems with the weak acid, where they give you the pH and you got to figure out what Ka is. Okay, similar idea here. So I'm going to write the chemical equation down again. In this case, caffeine is the base, water is the acid. And there we go. Okay, now they give us the pH value. They also give us the initial concentration of caffeine. So the initial concentration of caffeine is right there, 0.15 molar. This is a liquid. We don't need to worry about it. In fact, we don't need to worry about the liquid in any of these steps. Okay. This is initially going to be 0 and 0, right? Because when you, before you dissolve it, there isn't any of the products. It's after it dissolves and reacts and ionizes, that's when you're going to have the products. Okay? So essentially what we would do is we would say this. The products are 0, so we know that this would be minus x and these would be plus x. And so this one would be 0.15 minus x, this would be 0 plus x, and this would be 0 plus x. The issue is we need to know what x is to find Kb, and here's why. Kb is the concentration of the conjugate acid. Sorry there, let me erase that. The conjugate acid of caffeine. Times the concentration of hydroxide, products over reactants, right? Over the concentration of caffeine. We don't know what that is. So what we need to do is we need to figure out what x is, because if we figure out what x is, then we've got that quantity right there, that quantity right there, and that quantity right there. So the key is to figure out what x is, but that's actually pretty easy, and here's why. They give us the pH. So that's 8.45. So from that, the POH, very handy, 14 minus pH, right? pH plus POH is 14. So that means if you know the pH, the POH can be calculated very easily. 5.55. Now why is that important? That's important because hydroxide is X. So they're essentially, if we can calculate what the hydroxide concentration is, that gives us X. And we can plug it in here, we can plug it in here, we can plug it in there, and that means we're going to have all three of these values, and that gives us the value of Kb. So how do we go from POH to hydroxide concentration? We went over that in a previous section, 10 to the negative POH. So that would be 10 to the negative 5.55, which is perfectly fine, except that we like to have things in scientific notation. So 10 to the negative 5.55, so 5.55 negative 10 to the x. 2.82 times 10 to the minus 6 molar. Okay, now we got hydroxide, which is X. But we've also got the conjugate acid of caffeine, which is also X. Remember, these are the values we're looking for. And we've got the amount of caffeine that's left over at equilibrium as well. Remember, it's ICE, right? ICE. These are the values down here that we're looking for. Okay, we've got them all. So I'm going to go ahead and write it in the expression. It's the conjugate acid of caffeine times the hydroxide. So that's just x squared. So that would be 2.82 times 10 to the minus 6 squared, divided by 0.15 minus x, 2.82 times 10 to the minus 6. Okay, that'll give us kb. So that means we just need to square this and divide it by 2.82 times 10 to the minus 6. Oops. Let's try that again. Made a mistake. 2.82 times 10 to the minus 6 squared divided by parentheses 0.15 minus 2.82 times 10 to the minus 6. Okay, did I get that right? 2.82 times 10 to the minus 6. We squared it and then divided it by 0.15 minus 2.82 times 10 to the minus 6. And we get 5.3 times 10 to the minus 11. Remember, it's unitless because it's an equilibrium constant. And there you go. You figured out Kb. Okay. So this is the second type of Kb type problem. The first one is find the pH from an initial concentration and a known value of Kb. The second type is find Kb from a measurement of the pH and the known initial concentration of the base, right?